We had an NSF grant to introduce robotic students to clinical problems. And this is a new frontier for, integrating medicine and robotics, and we really wanted that to be reflected in the curriculum. So early on, my goal was to have them really understand what's it like to work in a clinic, what's it like to work with patients, what is it like for patients who have disabilities that might need to be addressed through technology.
And so what this class allowed the students to do was to get in and talk to patients, talk to clinicians, talk to the doctors, so that they could get firsthand knowledge of what they could do in terms of their research and why it's important and why it's necessary and why, as roboticists, we can really solve some major medical problems that exist today. So it provided that exposure that the students wouldn't have normally received in the classical classroom setting.
One of the best things I got out of the class was a perspective on how clinicians and their patients use medical technology. I think often as engineers we like to think of the big ideas or the highly technical projects that are challenging, and we think about ways we could revolutionize the way that the medical field works. But this class really showed us that oftentimes you can walk into a clinic and you can see that they have these really high-tech pieces of equipment, but that they don't really use them all that often. And a lot of times they'll opt for something like a pair of plastic circles over a high-powered treadmill. The reason for that is that a lot of times those pieces of equipment are really hard to use and to set up, and they take a lot of time.
I remember being really surprised looking around at how much low-hanging fruit there was. I was talking to the surgeons and the anesthesiologists, and they were saying, oh yeah, we really think that we could improve this medical pump, or we'd really like to get some of these wires out of the way. We'd like to have wireless systems. And I was really surprised because that's very doable technology, and I kind of realized a little bit more about the history.
As an engineer, our goal is to solve the problem. The first step to solve the problem is to find the problem. So by taking this class, we went to the Emory hospital to observe the problems exist in the clinical settings. And by talking to the patients and the doctors, we had the opportunity to learn and get further insight from patients and doctors.
I think this course is important because it actually brings I think from the engineering standpoint, it brings a functional perspective to the way physicians practice medicine, to the way patients interact with a physician and things that need to be done. I think a lot of times, we can come up with great ideas, but if it doesn't work well in the actual real-time environment, then it's not, it's going to go by the wayside.
I've seen a lot of research that is great, but just never makes its way out of the lab for whatever reason. And I really wanted my research to actually benefit somebody. And so I thought this class was a great way to, meet some of the people and really understand where they're coming from, who will ultimately be using my research. I guess it's easy to hear something, but when you actually experience something and experience where these people are coming from, so some of the issues that clinicians have, some of the things they wish were better, it forces you to rethink kind of how you approach a problem.
A lot of it, as engineers, we think of technology as sort of like the end-all solution to many healthcare problems, and it's really great to see that, well, I don't know about great, but it was informative to see that that's not the case, and that technology is really a very, very small part of what the clinicians.
So the goal for me was to introduce these students who are going to be making the technology that I'm going to have to use in the future to the actual clinical setting, so they could see what the patients go through on a minute-to-minute basis when they're in the hospital, especially in the operating room area, in the ICU, on the wards, and to see what challenges we face in a physical environment. So it's one thing to say we need this monitor to go from here to here. It is another thing to see all the traffic surrounding the patient as that monitor is moved from one place to another, and then also how busy it is in terms of getting things done in a certain order that on paper seems logical, but in a real setting can't always work the way you imagine.
I definitely learned a lot in it, and I would tell them that if they are interested in applying maybe research or other sorts of engineering applications to the healthcare field, I think that this is just an outstanding opportunity.